the more complex GPT-3 large language model based bot that I've been working on. I'm releasing the source code for this as well, so you can take it and incorporate that into your own bots for teams. But let me first do a quick demo. So I'm going to ask it how many humans need to be stacked on top of each other to be as tall as Starship. And by stacked, I mean, just to get a relative sense of how tall Starship is. So the reason I'm asking this is because I wanted to do some math. So it's going to have to first figure out the height of Starship, then the height of an average human, and then do the math. So pay special attention to this debug console over here. So the query I gave was how many humans need to be stacked on top of each other to be as tall as Starship. So it figured out that it first needs to do a search to get the height of Starship. So search in this case is using Bing because that's what I've set up, and I'll show how I did that. So it got the height of Starship, which was 120 meters. Then it did another search. I need to find out the height of a human now. So this is the thought it's having. Then it did another search to get height of a human. And it came back with 1.75 meters as the average height. And then it did the math, right? 120. So for doing the math, it's using another tool called calculator. So it used two tools in this case. It used search and calculator and got the answer. So how is this working? What is this tool thing I'm talking about? So this is using something called LangChain. Okay, LangChain is awesome. It's open source, and they've just released something that works for JavaScript. So LangChain basically gives you agents, and I'll talk a little bit about the React agent that they have, which is powering this thing. But the cool thing with LangChain is that you can give tools to your agents, and then the agent figures out which tool is useful at any given moment. So let me show you the code for how I instantiated and added the tools to my LangChain instance over here. So this is how I'm instantiating all the tools and then providing it to the agent that I'm instantiating. And then once I have the agent, I'm calling it for, let me make some more space over here. So when I have my agent, then this is how I'm giving it the user input. The input in this case is the activity text. This is the message. So I'm taking that as the input, giving it to the agent, and then taking the output from the agent and then returning that as a response. So it's pretty simple to integrate it. And this is powerful. So it has the notion of tools, like I said, and you can extend it with more tools. They do come with a bunch of tools out of box, not too many though for JavaScript, and obviously that's an area where I think would be awesome if more people contributed. So they have calculator, math, and SERP API. I'm having some issues using SERP, which was a good opportunity for me to actually write a Bing search tool on my own. So I'll walk through that next. But LangChain has a notion of tools, and that's what makes it powerful. So let's look at the Bing SERP API tool that I wrote. It's really simple. It's not hard at all. You just need to extend a class in this case called tool, and you can put all your logic inside the call method. And for Bing, I'm just using the Bing API again, pretty simple. So I'm taking the user input and then hitting Bing with that, getting the answers, and then I'm taking the first web page result and taking the snippet for that and returning it. Now this piece could be more robust, but I'm not looking into that for now for the demo, but you get the idea. You can hit another API from a tool, and then you can have this tool and plug it into LangChain. That thing is powerful. So how powerful is that? Let me give another example. So in this case, now I'm going to ask it for dad joke. And if we see in here, we should be seeing that it's doing another search. So it did another search. It realizes the thought it has is I should read some of the jokes to find the one I like. So it's first doing dad jokes, search, and then finding a dad joke and returning it. Yeah, there you go. Like, this is not an answer that I like, right? It did search, and then search gave it like a generic answer. We need to do better. We need better dad jokes in the world, right? So we're gonna build a tool for our bot. And again, the reason I'm going with dad jokes is because I think it's accessible, everybody gets it. But the real power here is, think about emails, calendars, messages in Teams, messages in Outlook, all that stuff. You can build tools for these things, and this thing can help you run those tools as needed to meet whatever objective you have. So let's get into the dad joke API. So this is the code I have, and it's similar to the Bing Serp thing that I wrote earlier, but I didn't write this code. That's the other big thing we have now, right? We can use ChatGPT. So LangChain has a notion of tools. Tools can work with external services, and you don't have to write code for all those tools. You can use ChatGPT to do it. So it's super awesome. Here's how I got ChatGPT to write code for the dad joke service that I'm using. So here's what I told ChatGPT. Here's code for a LangChain tool. I'm going to ask you to generate similar tools. Can you please learn this code and summarize what this code does back to me here? So this summarization piece seems to be important because without it, I saw it was messing up the code a little bit. So I pasted the code which I had written for the Bing search tool, and then it repeated back to me what the code was, and its understanding was correct. And then this is all I had to do. Okay, now I want you to generate code for a tool that makes the equivalent of the following curl call to fetch a joke based on user input. And I just gave it the curl. That's it. It generated the tool for me. So I took this code, copied it, and pasted it back in here. Of course, you don't want to just take the code that AI is giving you and pasting it in because, who knows. But the reason I said that is this code was good to go. This code, I didn't have to modify it. It does all the right things. So it's, let me make some more space. So I think there were some minor improvements it did, right? So one thing I didn't mention as much before is for the tools to work, this description string is really important. This is how the agent that we're using in here is mapping its thought to a tool that might be applicable. So it's looking at the descriptions to find the right tool. So in the tool that ChatGPT generated for the ICANN has dad joke service, it actually improved my code a little bit. It put these things in the constructor. And yeah, everything else was pretty awesome. I think the other cool thing I saw was it did this random joke thing. So it realized that this thing returns an array of results, and then did this random thing, which I didn't expect, but it totally makes sense because this service actually returns 20 jokes by default. Instead of taking the first one, it's doing a random index and getting that particular joke. I think that's cool. Okay, so this is how you write a custom tool, and I have actually disabled it because I wanted to do it during the demo. So let me enable that to show the improvement. So let's kick this back on again, and let me clean this up so we can just focus on the things that matter. Let me restart the convo here to clean the slate, and we're gonna ask it for a dad joke. So give me a random dad joke about dogs. So now we expect it to use the dad joke tool that I've added. Bingo, it does that. So it realizes I should use the dad joke tool. It calls the dad joke tool that I have. It gave it the input of dogs, and this is the answer it got back. It was raining cats and dogs the other day. I almost stepped in a poodle. That's cool. All right. So this is why LangChain is powerful. It has a notion of tools, and you don't have to author all those tools by hand. You can use ChatGPT to do it. So it's extremely powerful. So let me wrap up over here by talking about LangChain a little bit. So the agent that I'm using in here is called the React agent. It's based on this paper that I'll share as well. And if you look at the debug logs that I had over here, the output you saw was similar to this. So it's basically the prompts that are given to GPT by default. The examples we give GPT, or we in this case is LangChain, the examples are showing GPT that sometimes you need to break a complex user input down into sub-steps and then solve those sub-steps and then assemble the answer. So there's thought, act, observation, thought, action, observation, and this is what we had over here as well. So thought, action, observation. So I'm gonna share a link to this paper, and I'm also gonna share a link to the source for the React agent that's being used in here. But overall, I think this is extremely powerful. This changes everything, because you can now very easily have bots that can talk to external services based on the user input, and figure out the right services to talk to and get the answers back. Plus, you don't have to author all those integrations with those services by hand, and you can use AI to do it. So I hope this is inspiring for everyone. I'm going to share the source for this as well. Please let me know in comments how this goes, how this influenced what you were looking into. But I hope this was fun. Thanks for watching. See ya.